I would like to first thank Vardui Petrosian and the whole team behind her and all the other organizers for inviting me to this wonderful country. It is my first travel to Armenia, and I had already yesterday the chance to see your rich cultural heritage with the UNESCO World Heritages in the north of the country. But I would also like to point out what my guidebook about Armenia stresses, in saying that beyond all the cultural richness and nature, what's the most important thing in Armenia is the very friendly people that always welcome the visitors. And I can only confirm that from my first days here in Armenia. So it's a real pleasure and a privilege to be here. My talk today, my first talk, will be really an overview on what we know about carcinogens and how we identify carcinogens. And it will be really a high-level talk, not going into any detail on any of the specific carcinogens. Otherwise, we could do a one-week seminar, and this is not the time here. But if there's any specific one beyond that, we'll have specific presentations later, including from myself. I would really like to encourage you to ask me anything you want to know about any potential carcinogen, and I'm happy to answer your questions. With this introduction, let me really start with a number that also Elizabeth pointed out, with the 12.7 million new cancer cases in 2008. But this is only the current status. Based on estimates that had been carried out by the International Agency for Research on Cancer, there is a rising burden of cancer. And this estimate is only based on taking forward the demographic changes of populations, not yet including changes in risk factors. So by 2030, we expect almost a doubling of the cancer cases that we have now. And even more problematic is that the majority of this increase in cancer burden is expected in low and medium income countries. And these are the countries that are the least able to deal with their health services with this rising burden of cancer. And not only therefore, but as a really fundamental principle, prevention is the single most effective response to those challenges. And of course, particularly in low and medium income countries, where these health services are least able to meet these challenges. Now, what is the first step in prevention? We need to identify what's causing cancer to be able to prevent exposure to these. And as Vardui pointed out, I'm the head of the monographs program, and one of my predecessors called it the Encyclopedia of Carcinogens. This is really all about every carcinogen you ever wanted to know, and all of these monographs are available in full text. These books are sometimes up to 1,500 pages for your free download from our website. And the monographs look at all kinds of environmental carcinogens in the broadest definition. Everything that comes from the external, that's not genetic, can be classified and evaluated by the monographs. It started out with chemicals, complex mixtures, occupational exposures, but then broadened the scope, including also physical, biological agents and lifestyle factors. And by now we have evaluated more than 900 different agents, several of them repeatedly when there was new evidence available. And there are now 110 known human carcinogens, and you'll see in a later slide why Elizabeth had 107 and I have 110. And beyond that, there are more than 300 additional ones that are probably or possibly carcinogenic to humans, and you'll understand in a moment what all of that means. Now, this is really being used by national and international health agencies, predominantly in forefront, of course, WHO. So we provide the scientific evidence as a WHO research institution on cancer. WHO takes it forward with the participating states to policy implementation in the individual countries and globally. And so this is really the source for what's causing cancer, and it can be used also, of course, by the individual countries to prevent exposure to known or suspected carcinogens. And the monographs program is really a unique process. It is not us, the monograph staff, that writes up these monographs. For each meeting, we invite the world's leading experts on each of these topics. And over the more than 40-year history of the monographs now, there have been more than 1,000 scientists from over 50 countries that have contributed with their expertise to developing these monographs, and then in the end coming up with a consensus evaluation. What do we know from the published scientific evidence about a specific exposure? This slide is a complicated one, and I will not go into all the details, but this is summarizing essentially the evaluation scheme of the IARC monographs program. So on the left side, you see the evidence in humans. What do we know about the cancer in exposed humans? And you see the three classifiers, sufficient, limited, and inadequate. On the top row, you have the evidence in experimental animals, cancer bioassays, exposure to specific carcinogens or suspected carcinogens in controlled experiments. And you have the same classifiers, sufficient, limited, inadequate, and evidence suggesting lack of carcinogenicity. And in the first step, these two lines of evidence are combined into an overall evaluation. Now, whenever there is sufficient evidence that something is causing cancer in humans, it is a group 1 carcinogen. We know it's causing cancer in humans. However, if there is less than sufficient evidence in humans, but there is sufficient evidence in experimental animals, in these controlled experiments, it has been shown to increase the cancer risk in particularly rodents. Then it depends on the other available data. Say if there is just these data in experimental animals, it's a 2B, possibly carcinogenic. And that is based on the long history and expertise that if there is an increased risk of cancer in animals, that is at least reason for concern that it could also cause cancer in humans. If there is additional data in humans, if only limited, because we cannot exclude bias or confounding, or the database is not robust enough, then it would be a 2A, probably carcinogenic to humans, because there is additional sign in humans that it's causing cancer. Now this is combining the human cancer and the animal cancer data. Now, over the last decades, there is ever-increasing and important new data on mechanisms of carcinogenesis. We understand better and better how an exposure is causing the cancer, the individual molecular steps from the inhalation to the absorption, the metabolism, DNA damage, and how all of that interacts with the pathways of cancer causing. And so this kind of data can be used for upgrading an agent. Say, if there is only evidence that it's causing cancer in experimental animals, but we have strong data on the mechanisms that have been shown how it's causing cancer in the animals, and in parallel showing the same steps in the humans. Even if we don't have the full proof of cancer in humans, that can then also be considered as a known human carcinogen based on mechanistic data. It can also go the other way, but we have very strict criteria there. If we know it's causing cancer in experimental animals, but we know this is only one specific cancer site, and we know this is based on a mechanism that cannot operate in humans, then the concern that is created by the cancer data in the animals is, in course, not of concern to humans. But as I said, we have to apply very strict criteria there to make sure that we don't kind of take this too lightly. Now, I'll come back to that. I think essentially the most important message from this complicated slide is group 1, we know it's causing cancer. There's different ways to get to it. Most often it's based on cancer in humans, but it could also be a combination of different lines of evidence. Now, on the occasion of the 40-year history of the IARC monographs and the volume 100 of the IARC monographs, we undertook a broad effort to update all the critical evidence on all the known carcinogens that have been identified in the history of the monographs program. And we wanted to go beyond and more systematically identify the tumor sites of all the cancer-causing agents in the humans, and also update the plausible mechanisms, because, as I mentioned, there is much new evidence and literature there. And we want to take forward all this accumulated evidence to see if we not only look at a specific agent, say asbestos, or chromium, arsenic, nickel, but say look at all the metals together. Can we learn more about the mechanisms or the sites affected? And this will probably be available. We have held 2 workshops. It will probably be available towards the end of this year. Now, we organized it in 6 volumes because it was really too much for one meeting, and this highlights the different meetings. What I will talk mostly about today is the 100C meeting, about metals, particles, and fibers, and the 100F about chemicals and other occupational carcinogens. Now, I mentioned that we also have tried with this volume 100 approach to systematically identify the cancer sites affected by certain exposures. This now will allow the monographs program and you as a user of the monographs program not only to look by exposure, say asbestos, but also to look by cancer site. If you have a relative that has a cancer and you wonder if that may have been caused by occupational exposure. If you're an occupational physician and want to have the latest evidence on specific cancers and their causative agents, then you can now look by cancer site. And this is something that is not yet available online, but we hope to make this available online during this year. Now you can, for example, type in liver cancer, and then this will give you some results on different histologies of liver cancer. You click, and that's probably too small for you to read, apologies, but then it will list you all the known factors that increase the risk of liver cancer. Here, of course, you have the hepatitis B, hepatitis C viruses, aflatoxins, etc. But this is now only from the monographs perspective. We also want to use the other rich data sources at the agency. So, for example, in clicking on the cancer, you can directly link to the WHO Blue Books. That is the definition of the pathology of the different cancers, and we're directly involved also in the development of the International Classification of Diseases for the neoplasms, for the cancers. So you get all the details about the specific cancer, what is known, and then you can also again link over to Globocan, which is a database of descriptive cancer epidemiology. And you can search it interactively the way you want. You can search about the cancers in a specific country by gender, or you can search for a specific cancer trend over a certain period, whatever you want to know about cancer descriptive characteristics. So this is one portal entry for you to know all about cancer. Beyond the update of the individual agents that we did in the volume 100, there is some more general lessons to be learned. And one of these is that with further research on specific carcinogens, this research finds additional proof for additional cancer sites being affected. And I have one example here, for example, alcohol drinking. It was very well known that alcohol drinking increases the risk of upper airway digestive tract cancers, liver cancer. But with this latest monograph, that was in 100E, we also identified breast cancer and colorectal cancers being caused by alcohol drinking. And knowing about the high incidence of breast and colorectal cancer, the burden of alcohol-related cancers is really importantly increasing with these newly identified sites. This is also important, and I'll have another slide on that, that often the occupational setting is an ideal setting to identify environmental carcinogens in the broadest sense. Why? Because we have relatively easily to follow occupational cohorts, exposed groups of people, and we have strong contrasts of exposure, relatively high exposure on the one side and no exposure in the general population. And so while, for example, radon, and particularly radon decay products and ionizing radiation, was first identified as a human carcinogen based on studies in underground miners, the new evidence now also shows directly from epidemiological studies, not just from low-dose extrapolations, mechanisms, etc., that indeed there is also an increased risk of lung cancer, from environmental exposure, that means indoor exposure to radon, particularly in certain regions that are affected by high levels of radon. And as I mentioned before, the use of mechanistic data to identify carcinogens is ever accelerating. So, for example, in one of the recent meetings, we identified some herbal remedies that increase the risk of upper urothelial tract cancer. But at that time, we could not tell for sure which is the specific agent that's causing it. And with the new data that were accumulated within less than 5 years, when we updated this evaluation in the context of the Volume 100 meeting, based on specific DNA adducts and specific transversions from AT to TA in TP53, a tumor suppressor gene, sorry, we could identify that it is indeed the aristolochic acid that is causing the cancer from these herbal remedies. And this has now much broader implications. For example, it has also been shown in traditional Taiwanese herbalists that produce these herbal remedies that they also have an increased risk of these upper urothelial tract cancers. Now, you could think after 40 years of research, in fact, originally this started with a request from WHO Geneva, the headquarters, that the IARC just created at that time should produce a list of one final definitive list of human carcinogens. And after 40 years, we still identify new carcinogens with new research. And this is just the latest 3 new group 1 carcinogens. So 107 from Elizabeth's slide plus 3 makes 110. And this is the last 3 meetings that we did, 105, 106, 107. And we also always publish the new findings very shortly after the meeting is finished in the Lancet Oncology in a 2-page summary report to give you the rationale and the new evaluations. So we identified exposure to diesel engine exhaust as a human carcinogen causing lung cancer. And I'll have another talk later specifically focused on diesel engine exhaust. We also identified trichloroethylene as a cause of kidney cancer. And we identified polychlorinated biphenyls, which are persistent organic pollutants, as a cause for skin melanoma. So a new 3 carcinogens. And there's probably more to discover. And we also advertise on our website the upcoming meetings, which we usually announce about a year ahead of the meeting. And in 108, we will again look into some drugs and herbal remedies. But I would like to point your attention to the one that we will do in October this year on ambient air pollution. So this is the mixture of the mixtures from transportation, from mining, from you name it. And this will certainly be a very challenging meeting, particularly in the end. What is the agent, what is the exposure that will be evaluated? Every 5 years, roughly, we have an advisory group meeting, external experts to advise the monographs program and future priority. This is from the last such meeting in June 2008. We will soon have another one, probably in early 2014, and giving us some guidance on what should be the new agents to be evaluated by the monographs program. And you can see here air pollution. And all those in red had never been evaluated before. So there's still a lot of things to be done by the monographs program. And as I mentioned, there might also be the need for repeat evaluations if there's new evidence that might change the classification. Now, this was the broad picture of the monographs program, and I will only have a few minutes now, not to take away all your coffee break. Working together with Elizabeth, we have almost taken away your coffee break. This is about some exposures that are important in mining. And I mean, you have really to start with ionizing radiation. It was about 1,000 years ago in the 1100, I think 83, that it started in some ports of eastern Germany with a cry for silver and mining for silver, which now has more than 1,000-year history, or almost 1,000-year history of mining for different metals, different ores over this long period. And it was in this context that in the 16th century, in 1533 and a little bit later, Paracelsus and Agricola identified that these miners, in fact, have a really very premature mortality. At that time, it wasn't clear. They called it phthisis, or it was some kind of consumption of... it wasn't clear. But it was in this context that it was later identified that it's radon and its decay products that, amongst other exposures, caused that increased risk of cancer in these miners. And by now we know, and I won't go in any of these details, that different forms of ionizing radiation, depending on the different routes of exposure, can affect almost every cancer site. It depends if you inhale it, if it's injected for treatment, etc. And the monographs, volume 100D, have summarized all the evidence about the different types of ionizing radiation and its relation to cancer in humans. This is a little bit more in detail what I mentioned on an earlier slide about radon. You can see here the white boxes are the data for the low-dose exposure from underground miners, and the black boxes are from epidemiological studies on indoor radon. And the bottom line of this complicated slide is that the low-dose extrapolations from the occupational studies fit very well with the direct observations in the environmental studies, which is, again, an important general lesson to be learned, that what we learn from the occupational cancer identification can be used for environmental prevention, even if we don't have detailed data on these. Another one that must be mentioned when you talk about mining is asbestos, and also Elizabeth mentioned that. Asbestos is the most important occupational carcinogen on the global level, and in the volume 100C we reconfirmed again that all forms of asbestos, including chrysotile, are carcinogenic to humans. And we also, beyond the mesothelioma and the lung cancer, established that asbestos causes also cancers of the larynx and the ovaries. And that was kind of a surprise finding from meta-analysis that really showed a clear relationship with asbestos exposure. But it's also important to remember that colorectal cancer was very close to sufficient evidence. In fact, the working group there was split half-half if it's sufficient or limited evidence. And that would again really contribute an important additional burden of cancer from asbestos, because that is a very frequent cancer. And then there's limited evidence for other cancer sites, pharynx and stomach. Another one that is important in general for underground mining is silica dust. And there's, again, sufficient evidence in humans for the carcinogenicity of silica dust, group 1 carcinogen, and it's causing cancer of the lung. This is also supported by sufficient evidence of carcinogenicity in experimental animals, particularly on quartz. The mechanistic data so far are not straightforward to interpret. Most genotoxicity studies are negative. There is evidence on oxidative stress, inflammatory response, but the carcinogenicity may also depend on inherent characteristics of the crystalline silica or other external factors affecting its biological activity. But bottom line, it's a known human carcinogen. Now, just reading a bit about Armenia.